Mr. Joanne, and I'm here to help with worksheet 4C2 and number 1 in particular. Um, we are going to be doing this in this first video with graphing. And then the second video, we're going to look at it from a non-graphical perspective. And the reason for the non-graphing perspective is that very often in linear programming problems, you may have more than 2 or 3 variables. If that's the case, graphing is not always the best solution path. So we are going to first look at it in this particular way, and then we're going to look at a different way of looking at it in another video. So in this particular case, in order to do this, we're going to graph the feasible region. We're going to find the coordinates of the corner points and evaluate the function at each corner point and find the extreme value requested. So the first thing we're going to do, we're going to be trying to maximize, in this case, the objective function. So the first thing we note is that we're going to go to Desmos. And in Desmos, it's simply www.desmos.com. You can start graphing, and in this particular case, you're going to see that graphing this function, the three functions, and then of course the x is greater than 0 and the y is greater than 0 or equal to 0. So altogether we're going to be doing 5. So we're going to first of all start off with 2x plus 3y is going to be less than or equal to 13. I'm going to move this down a little bit by just dragging it, just so that you can see, I think, all of this is going to be happening in the first quadrant, because x is greater than or equal to 0 and y is greater than or equal to 0. The next inequality is x plus y is going to be less than or equal to 5. Then last one is 3x plus 2y is going to be less than or equal to 12. In Desmos, what's very nice is that you can find the points of intersection, or in our case, the corner points, by just clicking where the regions intersect. And in this case, where all 3 of those regions intersect. So these would be the points. And again, we also have 0, 0. We are looking at the points that will be the intersection of all 3 of the graphs there. So these are the points. When you put in each of these points, by that I mean when you substitute the 0, 4 1/3, or 13 thirds, when you put that in, when you put in 2, 3 for the function, or for 0, when you put that in, then you will find which particular point is going to be the maximum point. And again, 0, 0 is one of those points also. But as you can see, 0, 0 will give you it won't give you a maximum point. In our particular function, we're looking for a maximum point from the objective function. And it turns out that the maximum point is going to be 2, 3. When you substitute the variables into the objective function, in each of these cases, you will get the maximum value is 2, 3. And if you're identifying the particular region, I'm sorry, I wish I could outline it a little bit better. I'm just sort of like taking the pointer and going around. this is the feasible region that you have right here that satisfies all of the 5 inequalities that we had. I hope this helps, and the next video will be on doing this in non-graphical methods. Thank you.